Hello, my name is Harshita Bondlamudi, and I'm going to talk to you about how linear programming techniques can be used to optimize operation room allocation. Due to limited resources, surgery departments are facing great pressures to maximize clinical productivity. Therefore, the Division of General Surgery at the Duke University Medical Center planned to use linear programming techniques in order to better allocate its operating room time while maximizing its revenue. In order to start formulating an LP, individualized data had to be gathered on operating room time, the case mix, total OR time used, and the professional charges and receipts. In the study, researchers queried databases for all relevant information. The next step to formulating the LP was to determine the assumptions and constraints that would be made. It is quite difficult to model every single aspect of the situation, therefore certain reasonable assumptions had to be made. In addition, the medical center required the following four constraints to be met. First, the operating room time for surgeons with a primary educational, administrative, or research focus was always constant. Second, OR time for the remaining surgeons was between 8 and 31 hours per week. Third, total weekly allocated OR time was constant. And fourth, elective operating room time for the 4 surgeons working in transplant surgery was set to 8 hours per week. In the table seen here, we see the number of hours that the medical center is currently allocated to each surgeon. Historically, this allocation has been based on each surgeon's total use of the OR time. The rest of the columns break down the OR time into 3 main measures: setup to cleanup time, patient in the room to patient out of the room time, and preparation to dressing time. Given the data shown in the previous slide, the average weekly revenue was $206,700. Before solving the LP, a proper allocation basis had to be chosen. Therefore, the researchers calculated the hourly productivity of every single surgeon using the same 3 measures detailed before. The table on the left shows the overall weekly revenue for each surgeon as well as the hourly revenue of each measure, whereas the table on the right shows the top 5 and bottom 5 surgeons in each of the following criteria: weekly revenue generation, hourly productivity of OR setup to cleanup time, hourly productivity of preparation to dressing time, allocated OR time, and utilization of setup to cleanup OR time. Looking at this table on the right, we can see that highly productive surgeons, like surgeons number 15, 16, and 8, have the least allocated and utilized OR times. Likewise, surgeon 23, who had one of the highest utilized OR times, is in the bottom 5 for hourly productivity. This shows us that the previous allocation measure of the total use of OR time was not an efficient basis for maximizing revenue. After performing allocation modeling on each measure, the setup to cleanup time measure was chosen. Using this model as a basis, the resulting LP showed that the optimal weekly revenue is $237,523, which is a 15% increase from before and results in a potential annual increase of $1.5 million. In conclusion, this article has shown us how a linear model is formulated in real life, and how linear programming techniques can be used in the field of medicine in order to optimize operating room allocation while maximizing financial returns. Thank you.